All right, question number 13. We're going to locate the critical points of f, use the first derivative to locate maximum and minimum values, and then we're going to identify the minimum and maximum value of the function over the given interval. All right, so we have f of x minus 2 times tan inverse and this interval is from negative square root of 3 to square root of 3. All right, so the first thing we want to do is find the derivative. Derivative of x would just be 1, and then we'll do minus 2, and then the inverse or derivative of inverse tan. So that's one that we will have in our course cheat sheets. So in our videos, we got our cheat sheets, and then we want derivatives. There's two different ones, derivatives and differentials. So the arctan is the same as tan inverse. So here on this sheet, it is 1 over x squared plus 1. I'm trying to check just to make sure, because sometimes you get different versions of them. The differentiation sheet. I'm trying to make this full screen so it's a little bit bigger. So here it shows it's inverse tan, and it's the same thing, 1 over 1 plus x squared. All right, so just be aware, arc sine, arctan, arcsecant, or sorry, those arc, when you see arcsine, cosine, arctan, those are the same thing as tan inverse. So 1 over 1 plus x squared. Right, so when we do the derivative, we'll get, and then the derivative of the inside using chain rule would just be 1. So here would be our derivative. And then we could simplify, we would need a common denominator. So we would just multiply 1 over x, 1 plus x squared, top and bottom. That's for the 1. This would be minus 2. Same denominator, simplify the top. So the 1 and the 2, you would subtract those, you get a negative 1. So our final would be x squared minus 1 over, we'll just write it as x squared plus 1. All right, so here's our derivative. We would set this equal to 0. You also got to remember that the denominator cannot be 0. So there's nothing that will make the denominator 0. If you work that out, subtract 1, you will get x squared equals negative 1, and x squared can never be negative 1. Negative times a negative is positive, so nothing on the denominator. Then we set the whole thing equal to 0. You would multiply the denominator, and that will give you x squared minus 1 equals 0. And then we can do a difference of squares here, and that will give us x plus 1, x minus 1. You could also just add 1 and then square root both sides, but factoring it may let you see it easier. So we get two values for 0. X equals negative 1 and x equals positive 1. So these would be our critical values. This is between negative square root of 3, positive square root of 3, to our limits. So we'll have a negative 1 and a positive 1. And so we will test a number between here, between 1 and 0, and between these two. Now we can pick a square root value, or we can just use a numerical value since we're dealing with a rational expression as our derivative. This is our f prime. I need to label this so I can identify it better. I'm going to let the calculator do the heavy lifting. So let's try to speed this up just to kind of get our process down. Y equal, I'm going to graph it just as it is. Now, if you don't have a calculator that can do top and bottom, you want to put the top in parentheses and the bottom. This one, I can do alpha, y equal, and then enter. It makes that fraction bar. And then we're going to do x squared minus 1. And then do our x, okay. Let me just clear this out because I made a mistake. Alpha y equal, x squared minus 1. And then x squared plus 1. Alright, so that looks good, just like our derivative function. We can graph it. I'll come back to this in just a moment. I'm going to go to the home screen and just find the exact decimal point so I can pick a precise number between here. So if I look at the square root of 3, it's 1.7. So a number between 1.7 and 1, we can just say 1.5. So I'm going to test 1.5 between these two numbers. I can type 0 and then a positive 1.5. All right, go back to graph. I'm going to click trace and I'll just try these numbers. So negative 1.5. We get a y value of 5/13, which is positive. That's the thing we're looking for. If we type in 0, x equals 0, we get a y value of negative 1. So this section would be negative. And then if we type in positive 1.5, we get 5/13, which is also positive. All right. So critical points are positive and negative 1. All right, find maximum values. All right, so this is going increasing, and then it starts decreasing. So that's going to be a maximum. Then it goes decreasing, and it starts increasing. So these values are going to give us a max. This is going to give us a min. We got to go back and plug these into our original function to find out what those max and minimum values are. So right now it's asking the location of a local max, and so that would be at negative 1. Alright, this one is asking location for the local minimum. And so since this is going from decreasing to increasing, that would be a minimum. So minimum located at +1. All right, and then we want to find the absolute minimum value and then the absolute maximum. So I'm going to go back here, go to y equal. I'm just going to turn this one off by going to the equal sign and hitting enter. And so that one will not graph. So if I hit graph now, nothing. I'm going to go to y2 and I'm going to type in our original function, x minus 2. Inverse tan is in blue, so I got to do second tan. Gives me the tan inverse of x. Alright, so I graph this. Hit trace. And then I'm going to input each of these values so I can see what we're looking at as far as maximum and minimum value. So I'm looking at f of negative square root of 3, f of negative 1, f of positive 1, and f of square root of 3. Okay. So I'm just going to type those in. I'm going to do second square root 3. That gives us a negative, I guess. I don't know if they're going to want the exact value or not. They're probably going to want the exact value. Let me look. Integer decimal rounded to 3 places. Okay, so they'll take an integer decimal. 3 places, negative 362. Negative 0.362. All right, we're going to do negative square root of 3. Same thing, negative 0.362. Nope, that's not negative, it's positive this time. And then negative 1.571. And then positive 1. We get negative 0.571. All right, so looking at these values, the absolute highest value is f of 1 at 0.571. The smallest value, negative 0.571. So those two local max and min are the absolute max and min on that interval. So absolute minimum value, negative 0.5. All right, and then the absolute maximum value. Positive 0.571.